Okay, on this last page, which is page 27, I'm going to talk to you about cases where we're disproving or showing that something rolls or MVT will not happen, which I always get the question about that, and then also a real-life interpretation of the mean value theorem. So the first part is when you're taking a look at whether the MVT or rolls theorem is a true scenario. We've given you problems where this actually occurs, but the question I always get is, does it ever fail? Does it ever not happen? So the biggest piece here, I guess both pieces would be continuity if you have a discontinuous function on the interval, which I talked to you about before where we had a vertical asymptote of x equals 0, but also differentiability. What if you cannot take a derivative of the function over the given interval? So differentiability is critical in these two pieces of the MVT. And if the function is not differentiable even in one place over that open interval, then the theorem won't hold and it just kind of falls apart from the very beginning, and you can't even prove anything. You can't even make a hypothesis statement. So here you're just going to be given a question that would say, it would be stated the same. Verify the hypothesis of rolls, and then find all values that satisfy the conclusion. So you would have to proceed as if you would any other time. So what we're looking at here is a graph from 0 to 6, okay, and I clearly didn't draw it to 6, I drew it to 4, because when I sketch this, we know that an absolute value graph is a V-shaped graph, and if I wrote this in standard form so that we could graph it without a calculator, it would be a negative absolute value of x minus 3 plus 3. So you should remember these characteristics from Algebra 2, meaning this is a reflection over the x-axis. The graph moves from 0, 0, the parent function, right 3 and up 3. So if I do that, 1, 2, 3, 1, 2, 3, I have a vertex right here. And if I were to sketch the graph, which is a reflection, it's just a sketch, so don't freak out. What we're looking at here is a graph that looks somewhat like this. Now, with this graph, we're going from 0 to 6, which is probably somewhere out here. The problem here is we have a sharp point. Therefore, the function is not differentiable over the open interval. So you would just make a statement that rolls, because that's what they're asking for here in the question, cannot be applied as f of x, you don't have to state the whole function, must be differentiable on the open interval from 0 to 6, and f of x is not differentiable, you cannot abbreviate, at x equals 3, because that's where the vertex is. So this would be a scenario in which the whole thing falls apart from the very beginning once you know the graph and you make your statement and move on. So there are some cases in which rolls or the MVT will fall apart. Okay, what if we had to apply this in quote-unquote real life? So the velocity interpretation. So we've actually talked about instantaneous velocity and average velocity. Instantaneous velocity would be the derivative. We talked about this at the very beginning when we first started taking the derivative. And average velocity is basically the slope of the secant line. So this is the slope of the tangent line. This is the slope of the secant line. Okay, we've already talked about that. This is f prime. This is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And what we're looking at is that the MVT implies that at least once during a time interval, the instantaneous velocity has to be equal to the average velocity. Okay, so we're going to show you a scenario here in which this would apply. So Steve is driving, okay, on I-95 from Springfield to Savannah, Georgia to visit his grandmother. And at 2 p.m., he is at milepost 110. So this basically is a point, okay? And then it tells you at 5 p.m., okay, he's at milepost 290. So you can figure out this person's speed, okay? So first of all, let's assume on 95. There's no construction, no detours, nothing. It's just a continuous drive. It doesn't say anything that he had any interruptions. And assuming that the posted speed limit is 55 miles per hour, we want to know if there's enough evidence to prove that Steve is guilty of speeding. Okay, guys, this is not about pulling him over, arresting him, or whatever. This is just showing, is there some kind of proof that he was driving in excess of 55 miles per hour? That's all we're doing. So we're going to use the MVT. So we need to state the hypothesis first. Okay, so we would state that, and remember, Steve is driving in a car. So the position of the car, because remember, we're dealing with real life, quote unquote, real life. And the position is continuous, meaning he's staying on 95 from 2 p.m. to 5 p.m. That's the time interval that we're looking at. So if we're talking about the position of the car being on 95, okay, we can also say that this position is differentiable on the open interval from 2 to 5. They're telling us that they want us to use the MVT. We need to prove this somehow. So our conclusion, okay, what we're looking at is the change in the position, okay, at 2 p.m., mile marker 110, delta means change, and the change at 5 p.m. at mile marker 290. Okay, we can't find the derivative of the function because we don't have a function, but we can find the slope or the derivative or the average velocity, basically. So f prime, which we cannot find, is the instantaneous velocity. But if we can figure out his average velocity, meaning if it is greater than 55, at some point, because we're taking the average of his speed over 3 hours, he was in excess of 55 miles per hour. So we're going to take S of 5, the position at 5 minus the position at 2. This is your time. This is your distance over your time, 5 minus 2. So this is 5 p.m. minus 2 p.m. So here we've got mile marker 290, our distance, minus 110 over 3. So this is 180 miles divided by 3. So this is miles, and this is hours. So his average velocity, this is the formula for the average velocity. Okay? His average velocity was 60 miles per hour. So if his average velocity was 60 miles per hour, he definitely sped. So that's all we were trying to prove. Okay? So we would state that the average velocity as a calculation and when I say via, I mean by way of the MVT, because this is what we used, okay, was 60 miles per hour. Okay, therefore, because they're asking us to prove it, Steve was speeding, or Steve was, let's say, driving in excess of 55 miles per hour at some point between 2 p.m. and 5 p.m. When it was and how fast he was driving, don't know. We don't have to prove that. Remember, this is an existence theorem. That's it. So this is an application.